Hi folks, Dr. Tom McNamara back again for our course in trigonometry. In this video we're going to discuss the unit circle. So the key idea is unit circle trigonometry. It's a little bit of a revision of the interpretation of the trigonometric functions that we discussed earlier in the course. So let's summarize what we've done so far. We have talked about right triangle trig. Okay, the plus side of right triangle trig, the good thing about thinking of the trig functions in this way is it's useful for lots of applications involving indirect measurement. The downside is this interpretation only applies to acute angles. Okay, you can't talk about right triangle trig if you're trying to figure out the cosine of 120 degrees, because you can't put a 120 degree angle into a right triangle. It just doesn't work. The original interpretation we had for the trig functions was as angles in standard position. Remember that we were taking the positive x-axis, rotating in the counterclockwise direction. So the good thing about that interpretation is you can apply that to any angle. You can rotate through an angle of 240 or 310. You can talk about a negative angle. You can't really do that with a right triangle. The disadvantage is that, if you remember, we talked about the way you compute the trig functions. For an angle in standard position, you take a point on the terminal side with coordinates x, y, distance r from the origin. Cosine is x over r, sine is y over r, tangent is y over x. Well, you have all those variables in the mix, and they're changing. So the unit circle definition aims to kind of get around this and not have to deal with changing r all the time. The one thing I want you to keep in mind as we're doing this is the scaled versions of the special triangles that we talked about in the last video. So if we are dealing with, let's say, a 45, 45, 90 triangle, hypotenuse 1, side lengths are radical 2 over 2. If we're talking about a 30, 60, 90 triangle, and the hypotenuse is length 1, then this has to be 1/2. And this is radical 3 over 2. Okay, I want you to keep those things in mind as we discuss this unit circle definition of trigonometry. Okay, so here's what I'm going to do. I'm going to give myself lots of room here. I'm going to be writing some stuff down. And I'm going to use this gizmo here, a compass, to help me draw a nice circle. Okay. Oh, it's squeaking. Sorry about that. That's okay. So I'm trying my best to keep the point of that compass right there at the origin. Okay. So very nice drawing of a, semicircle. Okay, so I am declaring that is the point 1, 0. So this right here, that's length 1. Now I want to talk about some of our special angles. Okay, so 45 degree angle would be right about there. Okay, so 45 degrees, or in radians, pi over 4. I'm also going to consider a 30 degree angle, which would put us somewhere right about there. I want to talk about the coordinates of these points I'm kind of highlighting. And a 60 degree angle would take us right about here. Okay? So 30 degree angle, which is pi over 6 radians. 60 degrees, which is pi over 3 radians. Okay, so if we're talking about this angle being a 30-degree angle, or pi over 6 radians, we can imagine putting this special triangle right here. So, unit circle, I'm not sure I emphasize this, but a unit circle is a circle with radius 1 unit. Okay, so the hypotenuse of my triangle is 1 unit, so that would fit right there. Okay, so the coordinates of this point, well, I go over radical 3 over 2, I would go up 1/2. Take this and picture it being right there. 45, 45, 90 triangle. Let me clean this up a little bit. So we're dealing with 30 degrees or pi over 6 radians. Over here we're dealing with 45 degrees or pi over 4 radians. The coordinates of my point would be radical 2 over 2. Over here, we got to imagine taking this, but putting the side length 1/2 down here on the bottom, so that the x-coordinate is 1/2 and the y-coordinate is radical 3 over 2. Okay, so this is if we're dealing with a 60-degree angle or pi over 3 radians. The neat thing about the unit circle is, even if we stick with the angle in standard position definition, x over r. R is 1 for the unit circle. So we really just have to focus on the x-coordinate. The cosine is the x-coordinate if we look at the unit circle. So it's like a simplified version of the angle in standard position business. Okay, so here's a neat thing to remember. Here's why I like to rationalize this denominator sometimes. Remember when we took the original 45, 45, 90 triangle and scaled the hypotenuse to length 1, we divided everything by radical 2. So instead of calling this 1 over radical 2, I said root 2 over 2. Notice we got 3, 2, 1. Radical 3, radical 2, radical 1, which of course simplifies to just plain old 1. Right? So root 3, root 2, 1. 1, 2, root 3. Okay? So very easy to remember. 3, 2, 1, 1, 2, 3. Now, we can kind of extend this. We can talk about angles in the second quadrant. If we know these, we basically get the ones over here for free. Okay, just take the x-coordinate and change it to a negative. Okay, so this would be moving that same length, except you're going to the left rather than to the right. So notice the x-coordinates changed, the y-coordinates remain positive. Okay, so you got 3, 2, 1, 1, 2, 3 down there. Okay, very easy to remember. So using this picture, we can get the sine and cosine for lots of different special angles. Okay, in our Canvas course, I'm going to put a link to a blank copy of the unit circle. I want you to take a couple of minutes and fill out the coordinates of all the marked points on the unit circle using this scheme. Focus on doing quadrant 1 first, and then use the results of what you have in quadrant 1 to get the rest of the picture. Okay, I know I didn't do the rest of it here, but you can kind of see the process. Okay, if you have this first quadrant, change the sign of the x coordinates and you get the second quadrant. If you have the second quadrant, now change the sign of the y coordinates, now you get this. Now change the x's back to positives and you get this. Okay, so you can fill out that whole picture just knowing what you have right here, and that's easy to remember. 3, 2, 1, 1, 2, 3. Okay, unit circle trigonometry, very useful for remembering the exact values of lots of special angles.